It's very wobbly. It's not you. It's fine. Yeah, it's fine. All right. I will begin with a word of prayer. Heavenly Father, we thank you for this day. I thank you again for these students and for sparing us some what could have been much worse weather yesterday, Lord. In your name I pray. Amen. Okay, so this is the, will we do this Friday, was it? Oh yeah, thanks. So the solution to mission 3 should now appear in course content. I set it to appear at 9:20, which was 13 minutes ago. So it should be there. I don't really have much to say here, except that most of you guys were, I can't, again, I haven't recorded the grades yet, but by and large, you guys are good on this. My only complaint, this is the only complaint I have that I think some of you might be unaware of, and like you might have thought you had a completely right solution, but not been aware, so that's probably the most important thing for me to communicate to you. Some of you have not written plus ... And like that's not a optional thing. Like you need the plus ... Because without plus ... it's wrong. All right? Like it's not true that that is equal to that. Right? At least if you're going to not put the plus ... you got to put an approximate over here. Something's got to give. We can't write equality without the plus ... Fussy math stuff, right? And Math Battle 3, I added, so most of this was already posted, and I haven't reposted this yet. Well, let's see, what was it, Emma? You mentioned problem 3. So I had here in problem 3, I had neglected to carry through there's an x up here, which I had not bothered to multiply in the final result, so I only had 2n here, but I was supposed to have 2n plus 1 because x multiplies the x to the squared, x to the 2n, right? So there was a typo in the original one I posted. More significantly, if we go to problem 8, I actually have a solution. Whoa, wait a minute, where is it? Here it is. So this was the one that I didn't provide a solution in my original attempts. And I should say, one of the things I meant to say here was that Cn is not equal to 0 so that you can use ratio test in the argument. That was my intention. And I think some of you did that anyway. I mean, I haven't looked at your math battle solutions yet, but I wouldn't be at all surprised to find out you used the ratio test even though you were not given that they're non-zero, right? Just guessing. But anyway, so if you know that that's the interval of convergence, you can calculate the ratio test, and it gives you this. So if that's going to be less than 1 for where it converges, and it doesn't converge outside where it converges, if you think about that, that forces you to put this, right? Because this is the distance from x to 2, and it's only less than 1 between 0 and 4, right? So that means that it must be that this is what? See, this x in here could be restated as the absolute value of x minus 2 less than 2, because it's distance plus or minus 2 from the center, which is 2. So that forces this limit to be a half, which I think some of you probably figured out. But so if that limit's a half, then you can calculate the ratio test on the g of x. And if I do that, I get that x minus 10 is less than 6. So it says that the open interval of convergence is 4 to 16, right? Then I got to check endpoints to be safe, right? And I thought, when I talked to you guys about this before, that there was some ambiguity there. Like it maybe or maybe wasn't the case that the endpoints were included. But after thought about it some yesterday, I realized, nope, not for this problem anyway. For this problem, there's no ambiguity because you can straight up calculate g of 4, and g of 4 works out to f of 0, which is given to exist. So 4 is in the interval of convergence. And similarly, if you calculate g of 16, it works out to what would have been, did I say f of 4? I meant f of 0, right? If you work out g of 16, it works out to this sum, right? But this diverges because the interval of convergence that's given, it's given to not make sense when you plug in 4 for x. And this would be a point of convergence for f, except that it's not. It's given to not be. So we already know that this series diverges because of the data which is given, which means that it's the same endpoint behavior for this particular example. I do think there exists a variant of this problem where this doesn't happen, but this isn't that problem. So anyway, that was the thing I hadn't done yet. So I don't know if I have anything else to... Oh, I will post... I wrote a solution to the bonus quiz, which I had forgotten about. I mean, I forgot... I'm looking through your bonus quiz solutions. I'm like, what was the question? I could not figure it out. So fortunately, one of you had written a date on your bonus quiz. So I was able to go back to the video and go, oh, that's right. It was one of my, hey, where's Zach? Zach's not here. It's tempting. But the other thing I've learned is making bonus quizzes adds grading to me, and so that's kind of a sore spot right now. So I just give you the answer. You can grade your... grade each other's. So anyway, so I will post this in course content. If you want to understand its context again, you can go back to the video from March 29th, and it's about the 41 minute, 47 second mark is where the quiz is actually written out. So. Yeah, so I guess that's pretty much all I got to tell you guys. I mean, there's a test tomorrow, right? What's the test cover? You're like Elizabethan literature, an exegesis of Micah. No, it's going to be calculus too, right? The stuff you've been doing work on for the last, 3 weeks. I'm pretty sure. Let us party like it's 3387. Yeah. Oh, so you're asking about the... So you... The super math. If I can, I think. Are you talking about what is it? Math. I don't think I actually have a link to this on my. It's like the first thing. Yeah, I know. But if you go to my actual website, it's not linked. This is the website you're talking about, right? That's actually an interesting question. I don't know if I know the answer to it without looking at it. Let's see here. Let's see here. Yeah, definitely 21, 22 is big. 23, 24, certainly 25 and 26 and 27 couldn't hurt. Those are old tests, yeah. Although, I mean, depending on the sequencing of topics, sometimes there's parametric stuff mixed into this test or something else. For you guys, it's differential equations, right? So that won't be really clear from any of those resources, 25, 26, 27. Parametric curves in the plane, calculus parametric curves, polar coordinates. So 28 and 29 we already covered on test 1. Because I feel like parametric equations is you guys' least favorite topic, so I thought if I do it early in the course, it puts the maximum amount of daylight between that and course evaluations. Oh, I shouldn't tell you that. Now I've just ruined the maximum effect of my subterfuge. But polar coordinates is on the final, and also on your mission 4 and the final battle, but not this test because we're not there yet.
The last battle.
What's that? The last battle?
No, the final battle.
see here. So also, I would say, in some limited sense, 35 and 36, like 35 and 36 just give you sort of general situational awareness. They're probably not going to help you solve a specific problem on the test, but they might be helpful just in terms of general, like I said, you know, where am I, what am I doing kind of thinking. But 37 and 38 and 39, those are probably representative of possible problems. Although, I found a new way to be malevolent to you guys, which is to combine the power series and the differential equations problems, right? Like, we figured out I could ask you things like dy dx equal like y squared e to the x cubed, you know? So find a power series solution to this differential equation. That's not a question I would have asked in here. And the reason that would not have been asked in here is because when this topic was originally presented, when these materials were prepared, it was probably done before power series were developed in that particular presentation of Calculus 2. So like I didn't have power series to calculate with in those. But now we do, so it's, you know, another tool in our arsenal which gives us a way to integrate things that, you know, otherwise would be very scary. So, you know, minus 1 over y, some constant plus the integral of, what is that? That's the sum, n equals 0 to infinity, x to the 3n over n factorial dx, and then by term integration, so we do 3n plus 1 divided by n factorial times 3n plus 1. And so there you go. We could solve y is equal to minus 1 over the constant plus that power series. There you go. Just to contrast, what am I looking at here? So tell me what I've boxed in red versus what I've underlined in blue. What's the difference? So what's underlined in blue is an implicit power series solution. Or you could just say solution, implicit solution. And what's in red, of course, is an explicit solution. And I would say via power series. I really shouldn't say it's a power series solution, because to say it's a power series solution would be to say that I had actually written C as a power, that y as a power series, and I haven't done that, right? It's actually minus 1 over a constant plus a power series. So, yeah.
On the mission, you also say, like, explicit general. What is it? Plus C?
Plus, well, maybe plus C, maybe not plus C. Explicit general. So we could have something like dy dx minus 3y equals to x. For example, find the explicit general solution. So I'd say, okay, so the integrating factor here is the exponential of the integral of minus 3 dx, which is e to the minus 3x, right? And, okay, great. So that gives me e to the minus 3x dy dx minus 3e to the minus 3xy equal to x e to the minus 3x. Reverse product rule. I'm doing what? I'm doing the integrating factor method, right? And now I got to integrate both sides. How do we integrate x e to the minus 3x dx? We do integration by parts, right? So that gives me minus 1/3 x e to the minus 3x plus 1/3 integral of e to the minus 3x dx. So minus 1/3 x e to the minus 3x minus 1/9 e to the minus 3x plus a constant. So yeah, I add a constant at the stage of the integration, but that doesn't mean that the solution has plus a constant, just literally, right? So as it stands, if I underline that and that, it again gives me a implicit, not power series this time, right? Just an implicit solution this time. But to find y, the explicit general solution, I multiply by e to the 3x on both sides, and I get y is equal to minus x over 3 minus 1/9 plus c e to the 3x. So it's not just adding a constant in this case. It ends up being a constant times e to the 3x, which appears in this is the explicit general solution. So, yep. Okay. Yay. I mean, I may well have made a mistake here, you know. Using the projector on the 4th floor, always a mistake, as you can see. But as long as you guys see it too, I'm okay. Right? triple top hat. Zach, that's a way of punishing Zach? All right, I will. What you said makes sense to me. What you said? Let us party like it's 41:51. Yes. Oh, look, a final exam. Oh, that's very disappointing. I actually put a final exam there. I was really expecting to be rickrolled. Aw. Usually, if I have a link to a final exam, it's a rickroll. Do you guys know what rickrolls are, or is that too old for you? Yeah. Okay. Yeah. It's part of modern meme culture. Do we have a course in that yet? Like memes 101?
It won't be as a modern thing, it'll be a historic thing. They won't ever teach it as modern.
Yeah.
But it won't be.
It's going to be like the influence of memes on presidency.
Honestly,
The influence of
memes got President Trump.
That's true. You have a good point. With Trump being in office, it's given all kinds of silly people like license to make ridiculous courses in the future because he made it presidential. Now you can have an academic discussion about Twitter. Right? Why not? Yeah, sure.
They talk about political cartoons all the time.
I know that was.
I have thought it would be fun. I've always thought it'd be fun to start tweeting. I would like tweet my progress in grading, you know.
I was my stats teacher in high school.
Like, oh, these people are such idiots. This is how I feel like mid-test. I always feel like, oh, no one understands anything. Because all you see is the errors, right? But then at the end, I add up the points. I'm like, oh, okay. They're not that bad. I was just only seeing the wrong things in the middle of the grading. This is my typical pattern. And sometimes you add up the points and then you're convinced that your pessimism was reality. But not always, not with you guys. So, you guys have other questions? Yep. Ah. That's a good idea. So let's see here. Suppose we want to calculate the integral from 1 to 1.3 of x. Well, let's see here. I'll try to keep it relatively simple. E to the x minus 1 cubed dx. Let's do to within 0.01 just to keep it calculationally not too onerous here at the moment. Now, first of all, I was, minus. Because if, so one of the things that I mentioned, what was that problem in the Math Battle 3? I mentioned this in the email, but let me actually spend a minute of class talking about it. So, go away. Shut up. back away. Shoo, skedaddle. I know. Well, until I sync with the LMS, you know. Oh, in Top Hat. Okay, so listen, guys. What I did here was to. I mean, first of all, this one was more work. You know, if I'm integrating from 1 to 1.2, I wanted to center at 1 to make the calculation nice. And so centering at 1 took me some work. After I did that, though, you know, this was the result of centering at 1. And so I just kept up to quadratic order, all right? And then this was the cubic term was this, right? And the cubic term worked out to 0.017 in this context. So I was like, all right, so I said, well, okay, so then, you know, the first two terms plus or minus the third, right? But the thing is, it's not actually true, right? In other words, my claim under the squiggle, 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 my claim is wrong. Because I'm applying, I mean, in order to make that conclusion, I would need to know that this is an alternating series, right? And it's only for an alternating series that you're sure that the next term that you're not including is as big as the error is for the whole thing. It's not true for other things, and that's actually the case if you calculate with Wolfram alpha here, integral from 1 to 1.2 of this lovely function, you get 0.60582. And as you can see, oopsie, this is actually how far? It's about 0.021, maybe a little bit more than that, like 0.026 away from the answer, which is further away than the answer. I mean, my error estimate is still kind of sort of ballpark, but not really, right? It's not true. And the reason is I had no right to apply the alternating series test here. So there's two reasons that this problem was inappropriate for the math battle. The one is that I didn't engineer the problem to be an alternating series. All right, that's really the only thing that's appropriate for a time test, unless I'm devoting a lot of time for you to work out estimates. We had a way to approximate series truncating using the integral test, but that requires a deeper analysis for the given problem. All right, so the alternating series estimation theorem is the one that's most reasonable for test questions. And this was not that. All right, so that's what made this a bad question for Math Battle 3, I will admit. So that's why I added a minus here, so that when I actually work on this, it's going to be an alternating series, which means that we can justifiably apply the alternating series estimation theorem, make it a good problem. So I just wanted to spend just a second talking about that, because that problem, you know, I like part of this problem, but it was not the best version of that problem. This would be a more appropriate version of that problem, something like this. Okay, so we're looking at integral from 1 to 1.3. And what is that? 1 minus x minus 1 cubed, right? Plus 1/2 x minus 1 to the what? 6th, right? And I'm just going to be lazy and stop there, all right? So what do we got? We've got, let's see here. I mean, this doesn't really matter. I mean, I can integrate the x. So, I don't know, whatever. I'm going to just say x. And then minus 1/4, x minus 1 to the 4th. Plus 1/7, oh wait a minute, 1/14? Yeah. X minus 1 to the 7th. Right? I could take that thing and evaluate from 1 to 1.3. So this one was a little bit easier than the one in Math Battle, because it's sort of already centered. Unless you do something very... Now, there's a subset of you who foolishly take this and rewrite it as e to the minus x cubed minus 3x squared plus the 3x minus 1. Now, if you were so foolish as to do that, well, then you can make the problem way, way harder, right? But don't do that. I mean, have some situational awareness. What are you trying to do? You're trying to, you know, from 1 to 1.3, so x minus 1 is a good expansion. All right. Focus. So what is this x evaluates from what? It gives us 0.3, right? And this is what? 1 minus 1, 1 minus 1.3 minus 1 is 0.3, right? What happens when you plug in 1? It's 0, right? That was the point in expanding about 1 here, is to make that happen. Right? And so, as a point of organization, what I would do with this sort of problem is calculate these terms separately and see what they are. That will tell me how far I need to go to get the accuracy I want, right? It may be that the first term is enough, right? What's 0.3 to the fourth divided by 81 over 10,000. Thanks for nothing, calculator. Divided by 4. 81 over 40,000. Again, useless. All right. So 0.002025 is that one. 0.3 to the 7th divided by 14. So this one's 0.1234156 and so forth. So given the statement of the problem, we could do what? Integral from 1 to 1.3 of e to the minus x minus 1 cubed dx is equal to 0.3 plus or minus 0.002, right? By alternating series. On the above, right? Yep. Be very suspicious of what steps are not written out by your instructor. So that should have been 1.3 minus 1, which is not, wait a minute. Okay, yeah, I'm right. Yeah. I just assume I'm wrong when you guys say something. I guess I should maybe adopt a slightly more optimistic perspective. But, yep.
Is that first step, the second step, where you apply the power series, just the power series dx with the substitution?
Right. I'm noticing that e to the u is 1 plus u plus 1/2 u squared plus 1 over 6 u cubed plus dot dot dot, with u equal to minus x minus 1 cubed. So I only kept to the first 3 terms, because I kind of knew that was going to be enough here. So I could, what if I added a 0 to my initial instructions to within 0.001? Then I'd have to do what? I'd have to keep the first 2 terms, right? Because only the third term is small enough to be smaller than 0.001, right? Does that make sense? Okay. Yeah, I typically ask one of these because it's kind of an important combination of ideas, right? One of the things we actually want to gain some proficiency in here is not just how to use power series, but how to know how good they are when we truncate them, right? And so error estimates for where that rubber meets the road there, so to speak, yeah. Yeah, something like this probably. Yeah, possible. Do you guys understand what geometric series techniques mean? So if I say, f of x is x squared over 4 minus x cubed, and I say find the power series expansion at 0 using geometric series techniques, how do you do that? So yeah, we have to divide by 4, top and bottom, so to speak, right? Odd. Oh well. Glad I'm not using that anymore. Uh-oh. Uh-oh. Oh. See, I can work for IT. I know their main move. Hmm? I mean, we can, well, anyway. Okay. Focus. So here, this is the sum, n equals 0 to infinity of x squared over 4 times x cubed over 4 to the n, making it n. So a is x squared over 4 here, and the radius, or the ratio here rather, for the geometric series is x cubed over 4. Find the IOC for this. What would the interval of convergence be? What don't you need to do in this kind of problem? It's almost as important to know what you don't need to do, because if you kind of half study and you get in this, if you just focus your attention on part of the story arc of the course, you'd think that every time we find interval of convergence, we use ratio test. But that's not true, right? We don't need ratio test for a geometric series. If the series is geometric, then how do we figure out the interval of convergence? We just look at this. That completely governs the interval of convergence for such a problem, right? So you just got to face the music, so to speak. In this case, this is x cubed over 4 less than 1, which is x cubed less than 4, which gives me that the absolute value of x is less than the cube root of 4. So therefore, the interval of convergence here is minus the cube root of 4, comma, cube root of 4. Right? Now, this one's too nasty for me to ask a recentering. Like, I would probably not ask about recentering for this one. But let's see here, see if I can come up with it. You guys, give me something that's not so bad to recenter. What's that? Oh, e? E to the x? Centered at what? Centered at e? All right, that's just weird, but okay, fine. Let's get nuts. So, I mean, I don't know. Honestly, folks, like this one, this one's so simple that you could just use Taylor's theorem and differentiate, right? I wouldn't take that from you. But if I am going to center, if I'm going to use here, let me make it uglier. There, now it's unpleasant to do Taylor's theorem. But it's relatively unpleasant, relatively less unpleasant to do this, which is going to give us right, which is going to give me e to the e squared times e to the x minus e squared times e to the 2e times x minus e. And so, I mean, this is just a generally unpleasant problem, but if I wanted to find the first 4 non-trivial terms, then this is a pretty good approach, I suppose. Right? Because I could just, I don't know. I'm on the fence here about whether or not Taylor's theorem is still easier. I probably don't need to write the fourth order term. I mean, it's fairly apparent that you have a non-trivial constant, linear, quadratic, and cubic term, right? So if I'm interested in the first four non-trivial terms, I didn't really need to even write down this, right? Like this actually was irrelevant, didn't matter. And so then you can multiply and, start figuring out what the answer is. What was the question over there? What's that? Oh, I added 0. Let me. This to this? This to this? This to this? This is squaring out x minus e plus e squared, thinking of x minus e as its own kind of thing. This is like a plus b quantity squared, which gives me a squared plus 2ab plus b squared. Thinking of a as x minus e is how I think about it. And then, there's more stuff. I don't want to do more on this one, but you could see that you can collect terms to get the first 4 or 5 terms without a lot of work, relatively speaking. Just let me do one last example. I won't do all the details. Let me just... What if you had something simpler, though, right? Like, I don't know. 1 over, 6 plus x, something like that. You want to center at x equals to minus 4. How would you, this one would be much easier, right? Same idea, basically, but this would be 2 plus x plus 4, right? So sometimes you don't have to add 0. You just have to think about what you have versus about what you want, which is x plus 4, right? And then you factor out a half. And pretty much you're done. And what's the interval of convergence here? What would the interval of convergence be? What does it come from? Absolute value of x plus 4 over 2 less than 1, right? So if you work that out, it gives you absolute value of x plus 4 less than 2, also known as minus 6 to minus 2, I think. Yeah, it's the IOC. This is probably a better test question than that one, right? So, anyway, I'll see you guys tomorrow. And I will email you guys once I have these sitting outside my office, okay? Oh, yes, please. Thank you.